It's time to start the next session in this room, and we are going to move to Java 17 in production. I won't dare try his name, so I will just call him Axe. Give him a big hand.
Hello, Jfokus. It's my huge pleasure to be here. Welcome to my talk called Staying Java Current in Production, or as I like to call it, Upgrading Java Crazy or Crazy Not to. My name is Andrzej Grzesik. I know that's complicated. This is why my email is ax@revolut. If you want the slides, drop me an email. I'll send them to you, no problems. Of course, my opinions are my own. My mistakes are my own, and I apologize upfront for them. About me, I'm proud to be a Java champion, a Java man rockstar. I also run a conference, run the Polish Java user group. I'm involved in communities, like speaking at conferences. Have been to Jfokus before, if my maths is correct, 10 years ago, which is scary. And I'm so happy to see you all in person, because this is amazing. If you have any questions about the talk, you can, of course, raise your hands, and I will try to notice, but the lights are intimidating and blinding, so apologies up front if I don't, so let's talk afterwards, just in case. If you have questions about Revolut, we'll prioritize the talk-related questions, but let's talk outside. Obviously, Revolut is hiring, but who isn't right now? But I'm part of Revolut right now, and if you're interested, that's a good conversation subject as well. And I like dry jokes, because they remind me that I need to drink water when I'm speaking. So, some of you might know this excellent gentleman from Twitter, and Sharat tweeted this, in March. So Java 18 came out. You probably knew this. But somebody also noticed that Java 8 is now more than 8 years old, and time flies, that's all I'm going to say. You probably know about the Java release calendar. If you don't, it's a very good conversation subject for me or to anybody from the Oracle booth. I'm not going to cover this. I'm just going to show you one thing from here. Release cadence, we're used to having an LTS release every 3 years, but it has been proposed by Mark Reinhold to have an LTS release every 2 years. This is, according to this blog post, a proposal. We'll see what happens, as always. If some of you are a bit sleepy after lunch or conversations or overwhelmed with emotions, the too long didn't read version of the stock is. If you want to upgrade today, if you're around 8, move 8, 11, 16, 17, soon you should be just upgrading 11 to 17. And I will not be covering new features of the JVMs in the stock, because there are many excellent talks which cover exactly that material, and that would be overlapping. Now, because we are in person, what we can do is this. Who is using Java version before 8? Raise your hands. I see a few hands, as expected. Who is on 8? I see roughly 1/3 of the room. 9 or 10 we're going to skip for the interest of time. 11? Again, well, let's call it a bigger 1/3, maybe close to a half, and then there are some other versions. We don't have to go through all of them. But the thing is, if we ask the community, depending on where we ask and who we ask, we're going to get different opinions about that. Those are just some random different Twitter polls about which Java version are people on. They are not precisely meaningful, because they all say different things. And then we can look at things like the New Relics JVM, state of the JVM report, and one that comes from March 2020 says that JDK 8 was the prevalent Java version, which is probably expected, normal, and happened and worked very well. And then they have released, SNCC actually released a different report which suggested that 11 is now the most popular version in June 2021, so half a year ago. Almost a year now, actually, time flies. But then New Relic, very recently, released a different distribution. What is the conclusion of all of this? What is the meaning of what I'm showing you? That there is no single answer to the question of which Java version, how many people are using. And it probably doesn't matter, because with millions of developers out there, with exactly 3 billion JVMs always out there, the distribution is whatever it is. It doesn't matter that much. What matters is upgrading, and if you are working with something that could benefit from new JDK versions, it's probably useful to upgrading. But also, because in the new release cadence and in this current world, we have a choice of vendors as well. There comes a question of vendors. Vendors, so who makes the JVM, who ships the JVM that we would be using? According to SNCC, the distribution could look like this. According to New Relic, this distribution could look like that. The conclusion to you, it might be a choice that you and your organizations will have to make. I'm not going to say that you should use one versus the other, because it's not that simple. And if you have support contracts, if you're in a business relationship with another organization, you probably want to use them. But what I'm going to tell you is a story of a Java upgrade that we've done in the context of Revolut, of course. And to go there, we have to first go back in time a bit. Because the first upgrade that we went through 3 years ago, or over 3 years ago, was actually 8.2.11. So this started with when things were still using CoreOS, and so we were running Dockers within individual VMs. Obviously, CoreOS has been end-of-life similarly to other dinosaurs, and so on and so on. Why upgrade? Why did we decide to move off 8 into 11? Well, there is a couple reasons, and those couple reasons have to be looked at from a perspective of a financial company. So we like to move fast, we will move fast, but we cannot break things because we're storing and dealing with people's money. So we have to keep being up. Why upgrade? First, one of our company's mottos is get shit done, which means it's something that we will want to do, it's something that we will have to do. So why wait if we can do it and be done with it? Sounds simple, simple enough, but I know that there are organizations who don't follow that pattern of behavior. We do, so we did. We also want to keep things working. How is Java upgrades connected? How is upgrading Java connected to keeping things working? Well, it's very simple. If you are running on an old JDK that might have some vulnerabilities, then if you want to reduce your risk surface, you will want to move to one release that doesn't have those vulnerabilities. So a JDK update process, if you're processing things from the internet, is something that you will have to have anyway. And we would have to do this upgrade anyway at one point in time, but I already mentioned, if it's going to hurt in the future, can we do it now? Yeah, let's be done with it. And we wanted new features. We wanted the fixes, and we also wanted to have an edge at hiring, because people are excited about new JDK versions. And for most of you who work in technical organizations, you know that it's very difficult to come up with enough developers for what we all want to deliver, which means if this gives us an edge, of course we're going to use it. And there is that reason, which is the Java 8 to 9 string switch, which makes JSON happy, and that. Our context of JDK 8 upgrade was this specific build to 11, and we did it to all of the applications. And here, somebody might ask, maybe somebody is asking, but I cannot see, why didn't we decide to upgrade to 9? Why didn't we decide to upgrade to 10? Because when we were able to upgrade, and we were willing to upgrade, 9 and 10 were no longer maintained. And 9 and 10, given Java release cadence calendar, were not really supported. So nobody was, or we were not aware of anybody making backports and fixes. So 11 sounded like a stable choice, and 12 wasn't available, which means you can pretty easily time when we were dealing with this. And similarly, going into the future, because I do mention 17 in the title and in the subject and in some other places, why did we decide to look at 17 and not 13, 14, 15, 16, and so on? We actually looked towards 14, but we couldn't upgrade to it because of some of the dependencies, and now we just stabilized towards 17. And we also had to switch from Oracle JDK. Why? Because at the time of Java 11, Oracle JDK came with licensing restrictions that were affecting us. First of all, we couldn't build our own images without having a production license for it, which means get into a licensing contract with Oracle. We didn't want to do that. We couldn't redistribute. And what does it mean to redistribute? I'm not going to go into that language because I'm not a lawyer. I like building software. And running Oracle JDK specifically requires a license to in production? The answer to this is very easy. Just run OpenJDK. We all know that. You've heard it. OpenJDK is the solution to this. But there is a change that happened at the time of Java 17. The change is that, as you can see it on one of the screens, if your software is free to redistribute, you can use 17 without fees. What does it mean? There is an FAQ, but I already said I'm not a lawyer. I'm just going to tell you that there is an option. Maybe it is applicable to you, but the answer, the real answer in your specific organization's software case is talk to your lawyers, figure out if it applies to you. I don't know. Or maybe speak to Oracle people because they have a booth and they might be able to offer you some guidance. I'm not that person, sadly. But coming back to the aspect of upgrading your Java. You're running Java, you want to upgrade, or Java that you want to upgrade to, you have two ways of doing this. You do the whole thing, you compile and run on the new one, or you compile on the old one, but run on the new one. Which of the options should you pick? Well, we'll discuss that in the future. We went with option number one. We went Java 11 absolutely everywhere, runtime and toolchain, primarily because we could. Because also that simplifies life quite a bit. If you don't have limitations, well, you can. But if you have limitations, if, for example, at this moment you're using Hadoop and you cannot fully embrace 17, that's okay. That will change in the future. So it is possible to use a release of Java as in runtime and compile using the old one. If something is holding you back, that's okay. It's a technical solution that at the moment works. What it used to be in March of 2020, Cassandra, Grails, Hadoop, Kafka, Spring Boot, Thrift, well, to mention some from the top. Based on the list of advertised features, they were not supporting Java 11. Of course, situation has now much improved, and they all do, and you can use Java 11. But let's look at Java 17. Cassandra? Not yet. Grails? Not yet. And I'm relying on official documentation. If it's possible to make it work by hacking things or moving things around, maybe I'm just relying on official docs here. Gradle supports 17 happily, and so on, and so on, and so on. Which means the situation is improving. And I've had to update this slide a few times, but it's not everywhere available. Especially if you are heavy users of Hadoop or Spark, they are Java 11 centric. To the point in which you might notice that on the Spark point, Spark is going, or Apache Spark, not the Spark, Java Spark, is going to support Java 17 in release 3.3.0. Current release of Spark is 3.2.1, so congrats to those of you who noticed this tiny little joke there. What does it mean? That if you want to go 17 and you're in the Hadoop world, you might have to wait for some of the components to announce and make it possible. But there is one interesting thing happening, or going to happen. Kafka 4 is going to drop Java 8 support. Hibernate 6 requires Java 11. Spring Boot 3, Spring Framework 6 require Java 17 as a baseline. Juke, an awesome framework for interacting with databases, is going to baseline with Java 17. That means that at some point in time we are going to be forced to have migrated to a newer JDK, which will be quite big, given how many people are still using more dated versions of some of those frameworks. Well, this will be an interesting thing to maybe offer consulting on, or maybe offer blog posts on, or maybe do talks about. But there is definitely going to be a lot of software migrations happening. Now, how do you deal about it? Revolut is a company that uses microservices. Obviously, no surprise here. So we have things which loosely look like that. There is a service that depends on a service, or within a service you have an application that depends on a library that depends on a commons library. So how did we get to migrating all of our applications? The pattern was actually pretty similar. Compile an application using a new JDK. So make sure that it compiles. Then make sure that all the tests pass using the new JDK. And then try running it. We have a lot of unit and functional tests, which means if an application passes the testing suites that we have, and I'm talking tens of thousands of test cases or more, then we will feel confident that we can deploy this application into production using whatever setup we've had in the testing environment, and will be good. And this is exactly what we did. So we rolled it out to a few applications, then to more, then to more. And through the powers of infrastructure as code, that wasn't such a difficult change. After that, we went through the internal layers of the onion all the way down into the core. And now build tools. If you have a problem of migrating your Java applications or JVM-based applications, you might want to use some help. One of them is called JDEPs, part of the bin directory of your JDK, which shows module dependencies. For example, internal API usage. If you want to analyze your applications, or if you want to maybe prepare a report for the management about estimating the workload, this will come in handy. There is another thing that will come in handy is scanning for usage of deprecated APIs, which will show you basically what is deprecated for removal, what maybe some things actually got removed as well. So you can run it across, onto your code base and get results. And you don't have to run it from the bin directory. There is a Maven plugin for this, and there is, of course, a Gradle plugin as well. And now, assuming you are going through the migration, how do you run a new JDK on Maven? Upgrade the compiler plugin. That's what everybody knows. But then there are two useful things that not so many people know, or I keep meeting people who didn't hear about it. There is a plugin called Versions. Versions plugin in Maven has a few very useful options. One of them is called Display Plugin Updates. As the name implies, it can display which plugins within your builds you can upgrade and what are the latest versions available depending on different conditions. If you have a very old, maybe unmaintained, maybe unupdated, maybe unloved POM XML, there is a tool to make it better. There is also a similar command, display dependency updates, which, as the name implies, will show you how much behind you are on the dependencies and what can be updated. Quite awesome, quite nice, quite neat. If you are going to update the source, if you are going to update some of the things, you will have to go through the dependency updates anyway, because it will have to happen. Now, Gradle, how do you go 11? Gradle 5 is good. Gradle 6 is better. Gradle 7 is awesome. They all support Java 11. We're happy. If you're on Gradle before 5, my recommended upgrade path, just based on my personal experience, is do Gradle version upgrade one at a time. Because if you take 4 and try to move it all the way to 7, the intermediate upgrade messages that Gradle offers, they are going to be, some of them are going to be lost, some of them are going to be confusing. So do V4 to V5 to V6 to V7 or V8 when it comes out. Gradle and Java 17 works. We're happy. If you're going towards 11, you will have to add Jaxby onto your dependency list. As in, CodeGen has been taken out. If you rely on it, you will have to add it. Easy. And now let's have a look at some of the dependencies. For example, Mockito. Mockito, an amazing mocking library. I love it. I find it super useful, super powerful, and I think that's it's one of the libraries that actually defaults to whenever I'm starting a new project. Formally, it added support for JDK 11 in version 2.20.1. But then, if you go through the release history log, you will see different releases that mention JDK support in this version, this number, that number, that number, da-da-da-da-da. What is the meaning of this? Do you need to memorize those numbers? Absolutely not. What I'm saying is, even though a library or a framework or anything else announces JDK compatibility, there might be bugs happening as people explore more of the changes, as things change. And that's normal and that's accepted. And as we go forward, just pick the latest one and you are most likely going to be okay. But if you find a bug, it is possible that there is a new bug with something related to compatibility. It happens. This is software done by people, and that's just part of the process. Juke supported JDK 11 since version 3.12. We are on 3.13. We were happy. JDK 17 is going to embrace records in version 3.15, according to the plans I saw on Juke's blog. And then One interesting case that I'm going to mention about Flyway. Flyway, for those of you who don't know, a framework or a library to support database migrations. Very useful for testing, very useful for isolating builds, and so on and so on. Officially, it supports JDK 11 since 5.2.0, but we had issues. So what we did was move back to 4.2.0, and we were happy, and it worked, even though we didn't announce working states, and that can also happen. An old version maybe will not need to be upgraded or moved or touched if it's not broken. Also a possible thing. Now, languages. Groovy. A lot of you probably use Groovy because Spock. We use Groovy because Spock. We love Groovy because Spock. We also sometimes are very angry at Groovy because Spock. I mentioned that already. This mostly just works as soon as Groovy and Spock support a specific JVM version, until you get into very special errors, which sometimes seem like Java method resolution errors, but they turn out to be just mocking errors misplaying with Groovy. That's part of life. Right now, Groovy claims to be supporting Java 17, and it looks like a very good situation to be in right now. But what we, over time, and because of the number of problems or tiny little issues around Groovy and Spock tests specifically we have encountered, and the speed of their execution as well, we started writing more and more functional tests using JUnit or cotest, just because having a type-safe language means you cannot have assertions that are being missed or some other kind of errors. That's just our perspective. I'm not going to say that this is what you should do, because Groovy and Spock are very useful tools if they work for you. Scala, the story is almost boring. We were using a modern 2.12. We just switched versions of the underlying JDK, and it worked. End of story. Scala is actually kind enough to already share a version compatibility table. So they are already 18 aware. Maybe if you go to that website soon, it's actually going to be 19 aware. So they are very much forward-looking, very, very nice. And with one caveat. There was a mention on Scala's compatibility page that they do not support modules. We, in Revolut, do not use Java modules actively, so we don't care. But if you do, maybe that's going to be an issue. Maybe not. Kotlin supported JDK 9.12 since this particular version. 17 supports since 1.6.0. So just upgrade Kotlin and you'll be good to go. Really? That sometimes can be that simple. Moving on, VM options. People on 8 who will go to a newer JDK version, especially if they have the GC logging options enabled, will go through this JEP. This JEP basically changes the way you configure logging for your garbage collector, what it used to be and what it becomes. And there are some other flags that change between JDKs. And we're engineers here, so obviously there are two ways to do it. One of them is let's have a memory contest, and who can memorize all the changes and all the flags and how they change in a specific version. And that is a way, if you want a party quiz around a geeky audience, maybe that's a very good way of generating questions. But I recommend something else. Instead of memorizing, use a tool. And there is an awesome tool done by Chris Who Codes. The address is at the bottom. It's chriswhocodes.com, which tracks all of the XX flags for multiple JDK releases, multiple architectures, and it provides a description, and it tells you what it does, what it doesn't, when was it able, when was this flag added, what are some relationships between those flags. So you don't have to remember that. There is a tool, there is a repository, there is a lookup for it. Use it. And also, there is a jacoline.dev, which is a Java command line inspector or linter. So if you want to do an upgrade, you have a command line. If you maybe have half a dozen or half a thousand of command lines that you need to analyze, run it through that tool. It will tell you what's wrong, or it will tell you that everything is fine. Now, one thing that you will probably get into if you have a lot of tests, and I do recommend having a lot of tests, is if your tests, for example, interact with a database and they rely on timestamps and time precision. Time precision allowed by JDK between 8 to 11 changed. That's the ticket. There is some more description. The description, as I said, I'm very happy to share the slides, so I'm not going to discuss exactly what happened there. Basically, how it manifests is this. Instead of having 3 digits, you might get 6 if the underlying operating system supports it. How is that affecting us? If your tests expect something to happen within a specific time frame, and you're, for example, comparing times using 3 digits and expect exactly 3 digits to be there, but now your maybe string representation carries 6, is all going to break. What should you do? The answer is either adjust all of your tests, or better, make your own clock for test purposes that just offers as much precision as you want, and keep using that so that your test will not explode anytime the underlying operating system changes how much precision it offers. And of course, while upgrading, we discovered some bugs in the software, and we discovered even a bug in the compiler, which is very scary, but actually not that much, which some of them turn out to be duplicates of this, and maybe some of the generics had to be adjusted, which sadly occurred at runtime. But we managed to fix it. But I said, I'm not going to go through those details because you have the slides and it's very chattable or emailable. We don't have to waste the time. The important thing to notice, though, is JDK 11 defaults to using G1. And as of today, I can say this about using G1 as a default in production. We love it. Our services are not expecting crazy latency requirements. So tens of millis, maybe hundreds of millis for a response. And with G1, we're very happy. We don't have to spend human time looking at GC logs. We don't have to spend human time looking and configuring, tweaking the garbage collector for the services. For those of you who are still on older JDKs, the important thing to note is G1 in JDK 11 is a very different G1 to the one that's in the older JDKs. And similarly, G1 in JDK 17 is a different, or better, than G1 in the older JDKs. In short, JDK 11 full GCs are multi-threaded. Before 10, they used to be not, which means you're going to have a single-threaded stop the world, which means slowness. The important thing to us, people who run those services, no magic required to run human perception level pauseless. No magic, and also no human attention. It just works if the software that is being executed, for example, because of the database latency, is going to work. Which, if you have a couple hundred services, if you don't have to spend time on it, this is a win. This is a huge win, actually. And another aspect is we kept increasing heaps, and the biggest heap I've checked we have is around 32 gigs. And we didn't have to adjust anything. We just have heaps as percentages and of the available container size, and it all works. Less problems requiring GC logs. It's fun to analyze them if you need to, but we don't have to, which is even better, even more awesome. But we also started to have faster out-of-memory failures, which, if you know this one, and you know how long it can take to manifest, is quite nice. Now, what does it mean? It means that after moving to JDK 11, basically some containers starting dying on us. The bottom line is RSS of a Java 11 process would be higher than that of Java, a similarly configured Java 8 process. For a fixed container size, we needed to adjust XMX and XMS. If there would be an out of memory, it would happen faster. And we basically didn't notice any major differences when looking at 17. Now, language features. There is this tiny bit, that underscore. For those of you who know Scala, maybe other languages, it's a useful thing to write. Now it's a keyword, so you cannot use it as an identifier because the compiler will complain. Deal with this compiler. That's a double underscore. It works, perfectly valid, slightly more wide, but that's exactly what you need. We use it, and we use it in production code, and we're perfectly happy in production code if you don't care about whatever that value is. Another aspect is vars. Do vars help? Do vars not help? For us, they help a lot. We were cautious at first, and then we started adopting them massively. Why? Because they usually improve readability, and this added readability compounded over time, compounded over the number of lines that it applies to, is actually returning a lot of unlocked developer happiness, because you don't have to follow the typical Java ceremony of list equals new array list. You now say var something equals something. We love it. We use it everywhere. We also use default to saying final vars, if only it would be possible to write val in Java, but I can dream. And then there is this bit, Java flight recorder event streaming. If you're using a modern monitoring solution, which allows you to benefit from it, it's a very powerful tool. Why? Because it's a very good way to have insights into what happens in your production, lightweight and accurate. And so, upgrading. The first part of upgrading to 11, we've had a run through. But now there is the second part of upgrade that's still ongoing. Sadly, when I was writing the abstract, I was thinking, yeah, probably we'll be done, but we're not. So it was good that I said that we will be underway, because we're sadly not fully complete with it. Java 11 to 17, what happens? There is a bunch of interesting things that are enabled. This one will be useful to you. This one will give you useful things. Helpful null pointer exceptions. Instead of saying that there is a null pointer on line X, you can see what part of the expression was actually null. And it's something that used to be off by default. In 17, it is on by default. And this is what it looks like. Very good reason to move to at least 14. CMS, if you use it, if you rely on it, sadly it's going away. There is ZGC, and at the Oracle booth, you might speak to people who work on ZGC if you're lucky. We don't use CMS, we default to G1, so that doesn't affect us. Another aspect that you might run into is Nashorn went away, which we don't use. ZGC we didn't spend time on. Text blocks, sadly without interpolations. As a Scala user, I would love this to be so much more powerful with $signs or something else, but it's not there. And then there are some other changes in here, including pattern matching with all its variants and records. And the records is something that we are still getting our heads wrapped around, because we have to figure out a way in which we want our code to look when using records. But if you compare the left to right, which is the most common way of comparing records to a non-recordized code base, you see a huge win. And this is exactly what we're after. Under the hood, it looks similar because it is similar. But then, two things are going to surprise you, or might surprise you, when you're moving across JDKs. This is the strong encapsulation of JDK internals. Strong encapsulation of JDK internals means some of the things that were accessible without too much of a hassle now in version 16 need a flag, and the flag looks like this. Or they need a flag in 17, but the flag in 17 looks differently. Why do I mention this? Because some libraries, when in the migration journey, we were able to move up to 16 only and not put them all the way to 17. Or some of the things that you might run into your code bases might be easier to take up to 16 and then go 16, 17, rather than 11 to 17 all the way. That's why I mentioned this. Sealed classes we don't use yet. That's something that we don't use yet. And because I know this is Sweden, and it was recommended to me last time I was here that I should have prepared the questions in case they don't materialize from the audience. I have questions ready for you. The bottom line is, obviously, I want you to upgrade Java, and if you want the slides, drop me an email. I will respond to this email with the copy of the slides. I'm more than happy to do it, and I love answering questions over email as well. So, first question. Thank you for that. You're an amazing audience. Why upgrade at all? I'm very happy that you're following. So, one easy answer is libraries with more baseline. If you start a new project in the realm in which new Spring Boot, new Kafka, new whatever you are going to use, defaults to Java 11, Java 17, maybe, I don't know, Java 29 one day, you're going to have to use it, which means you're going to then have multiple JDKs in your organization. And apart from obvious reasons of not staying behind, there is a cost of maintaining multiple JDKs in your code base. There are performance improvements that are being put into every single JDK release. They are small. Think maybe a percentage point in some specific cases, or maybe single-digit percentage points. And your mileage might vary. You might observe nothing, but they are there. And over time, that means that you're getting free performance. And if you're spending a lot on the cloud bills, let's say 1 percentage point out of 10 million of your chosen currency in a year, you do the maths, you tell me if it's worth it. Another aspect is developer attractiveness. This is a thing, as in hiring smart, good developers is difficult because there is a limited supply. How to differentiate yourself from a very well-established, maybe using JDK 6 competition. Hey, we use 17. Come work for us. The software is shinier on our side. It works. And I would be saying something untruthful if I say it didn't. Obvious low-hanging fruit, JVM backend security fixes, lower operational requirements because you don't have to touch those garbage collectors in some specific cases. If you very much care about latency, and maybe you're doing something that actually has very strong latency requirements, it might be a bit more complicated. You still might need to have a human looking at it, but in microservices for humans powering a mobile financial super app kind of context, we don't have to spend time, and humans don't have to spend time looking at how the JVMs are doing. How should you approach the upgrade? Because a huge body of you here are still around 8. My recommendation as of today is go from 8 to 11. This should be easy. This should be not very painful, and this should bring the changes onto you. And then if all goes well, the upgrade to 16 and 17 is going to be much easier. There is going to be less moving things. Probably, if your code base is dated, has more than a few years, going from 8 to 17, if you're lucky, of course, well, if it works, absolutely, go ahead. But you might encounter problems around 16 to 17 time, and this is why I suggest using an intermediate step of 16. 8 to 11 or 8 to 17, as I said. The performance, are we seeing better performance with newer versions of Java? Yes, but it's nothing massive. In our context, this is not groundbreaking things that we would be screaming about. Tiny improvements added over a very big code base, but still they are there. You will see some blog posts which claim that there is maybe a major performance improvement in some specific string handling algorithm here and there. It all adds up. It makes your applications run faster. What about modules? Did we eventually get to using modules? No, still not. We use microservices. We're very happy defining interfaces between our applications using individual services and their interfaces. We don't use the Java modules. We don't think we will. If you are in a different setting, for example, making a library, making a toolkit, making a framework, maybe modules is something that you care about. We are not. Which JDK are we using? We're using OpenJDK. So not Oracle JDK, and not one of the other vendors. Some scenarios that might affect you. If you have a fleet of microservices, just feel free to follow what we did. If you have another example, for example, JVM isolated on a boat, and I spoke last year to somebody who actually has JVMs as part of data processing framework sitting in a ship in the middle of a sea or an ocean, then maybe in that specific case, you don't have to worry about that because there is no threat vector, there is no upgrade vector, as in it will be very difficult for the fish to maybe form a shape that will trigger something awkward in the software, but apart from that, it can stay there like it is. If you're stuck with an older component, an example is everything Hadoop stack. That might force you to remain massively or majorly around version 11 rather than going all the way to 17. But what then? If you're on 11, can you put some components forward? Can you put maybe use 13 or 14 in some places because it works. There are no problems with tests in your environments. The answer is yes, absolutely. Any JDK release, 11, 12, 13, 14, 15, 16, 17, same with 18 and probably further versions, they are fully normal, quality, first-class JDK releases. I know that some people call them beta sometimes, and this is completely inaccurate. They are fully compliant, TCK most likely, tested, production-ready, production-grade JDKs. Another question is, why would you consider non-LTS releases? Because you might see those incremental changes that I mentioned. One example, G1 in JDK 11 versus G1 in JDK 13 or 14. There was quite some improvements done. If you're, for example, running Cassandra, you will benefit from having less jitter in how the garbage collector works. So basically, times are going to be a bit more controlled. That might work for you. And if that works for you, then do it, absolutely. Also, for some of the non-LTS releases, there are support options. I was able to Google support offering via Zool. I'm not going to say that this is the only company that supports non-LTS releases because that situation changes. Talk to your JDK vendor, but there are things like that. And if you can't update often, though, which release should you focus on? My recommendation here is LTS, because this is what the community gravitates to, and this is what the community will default to, because this is what the LTS comes with as a label. And with that, now I really hope that you are successful with upgrading your Java and encouraging your organizations to upgrading your Java. And if you need the slides, you know where to find them. If you have questions, you know where to find me. Thank you very much for your attention. Enjoy the rest of Jfokus.